Good morning, class. Please open your textbooks to page 135. Today we'll be learning about chemical bonds.
We learned this last year. Is this really that important?
More than you think. Now, Cameron, name me 3 types of bonds.
Mr. VG, I don't have a clue.
That's okay. Now, Max, explain electronegativity.
I heard it's pretty shocking.
Cam, do metals share electrons?
They obviously share. Metals are too strong to lose electrons.
Not so fast, Junior. They're weaker than you think.
How are we supposed to remember that for the test? I have croquet in an hour.
I'm not sure. Why don't we check YouTube? The Chem Crew? This'll do just fine.
Yo, it's Be Rich on the Mizzle. We called the Chem Crew. We here to teach. Dr. Bods, lend me a beat. First things first, let's cover the bonds. Covalent, polyatomic, and ionic. Covalent bonds are always a sharing. Electrons together, no problems a glaring.
Ionic bonds, they're a whole other story. Non-metal stripping electrons for glory. Polyatomics, let me respond. 2 or more atoms with a covalent bond.
Covalent bonds don't tear, that's what the Q is. To understand this better, let's check our friend Lewis.
Differences are important, I'd bet it on my molar. If it's less than 0.5, then you got a non-polar. If it's greater than that, but less than 1.7, you've made it to polar covalent heaven.
But mister, you ask, what does all this mean? Let me explain it to you nice and clean. Nonpolars are pulling equally, left and right. Electrons stay in the middle, nice and tight.
Polar is different, one ian's extra large. Because of this, they have a slight charge. Yo, be rich, let's step it up a notch.
Alright, bro. Formulas are tricky, but don't get frustrated. Crisscross. Let me translate it. Take each charge and swap them around. Since they're on the top, let's bring them to the ground.
To wrap this up, nice and secular, we'll discuss bonds that are intermolecular.
You got London dispersion, the weakest of the 3. Two slightly different molecules attracted, you'll see.
Dipole only serves polars. Opposites attract, this song is almost over.
Hydrogen bonds, they're the strongest of them all. A special dipole type of bond as tough as a wall. It must contain an H and an F, N, or O. Alrighty, kids, it's time to go.
Study hard and you'll beat the odds. This has been Be Rich and Dr. Bods.
Peace.
Well, that was interesting.
That didn't help. I barely remember anything.
Yeah, that rap was whack.
How will we ever pass this quiz?
Well, students, what are covalent bonds always doing?
Sharing electrons together?
Exactly. A covalent bond is a combination of 2 nonmetals, like H2O. They share electrons between atoms.
So when they said ionic bonds are stripping electrons for glory?
What they mean by this is that ionic bonds are a compound of a metal and a nonmetal. The nonmetal has a greater pull on the electrons, and thus the nonmetal strips the electrons from the metal, giving each of them a full outer shell.
Alright, but what about that polar-nonpolar nonsense?
Well, son, even though covalent bonds share, it's not always equal.
Huh? Does this mean some nonmetals have stronger hold on their electrons than others?
Yes, some have higher electronegativity values, which means they have a higher pull on bonded pairs of electrons, giving them a slightly negative charge. The other receives a slightly positive charge. If the difference is between 0.5 or less, it will be a nonpolar. If it's between 0.5 and 1.7, it's polar covalent. If it's greater, it is an ionic bond, with few polar covalent exceptions.
So in H2O, oxygen pulls the shared electron closer to itself, making it slightly negative, and hydrogen slightly positive?
My goodness, the Chem Crew has really made a breakthrough on you kids. Cameron, explain the formatting of formulas.
We take 2 elements, crisscross them, and then reduce.
Well done. Format sodium oxide.
Sodium has a charge of +1, oxygen -2, that means it's Na2O.
That's right. Finally, there are intermolecular bonds. London dispersion is the weakest of them all, just like the Chem Crew said. It's a bond between 2 nonpolar molecules. Dipole-dipole bonds are the second strongest of the 3, which form polar molecules. The slightly positive and slightly negative ends attract each other. Hydrogen bonds are the strongest and made by having a hydrogen bond with oxygen, fluorine, or nitrogen.
I feel ready for the test now. Bring it on.
Little did you know, you already took it.
What are you talking about? You're more messed in the head than Dr. Bods.
I was secretly taking the test behind your backs, and you both passed with flying colors.
That's croquet with me.
Thanks, Mr. VZ. If we ever need help in chemistry again, we know who to call.
Ghostbusters.
No, the chem crew, you fool.